Hello everyone and welcome. Let's model this engine. So I'll start an empty part studio on the right plane, and with the circle and the origin, give that a dimension of 48 millimeters. Make that construction geometry, give that an offset of 8 millimeters. Continue with a line 96 millimeters in length. Then two circles here. Give that outer one a dimension of 112 and an equal constraint between those two. Continue with the line here up. Turn that into tangent arc and connect with a line. Make that tangent as well as here and here. Then concentric constraint here. Sketch is fully defined so far. Continue with another line. Search for that midpoint. Go up here. Take the arc command. Draw an arc here. Again, concentric here. Give that an outer dimension of 122. And a vertical, horizontal constraint here to the origin. Mirror that over this mirror line and apply a coincident relationship. That's it for our sketch. And pull that out here. And now let's go into our first extrude. I'll take the whole sketch here and make that a 22 extrusion toward me. Accept that. Make that sketch visible again. Continue with the 32 extrusion of that one circle here. And one more of that circle, 8 millimeters. All right. One last extrusion here of that region. Give that 80 millimeters. That's it. Apply a fillet, 22 millimeters of these edges here. And I can hide that sketch. And another one with 2 millimeters of that edge with tangent propagation, that one, and this one here. Can change the appearance of that to some grayish color. and do a part mirror over this plane, adding to our part. So let's make a pattern of parts. For directions, I can use just that cylindrical face. I'll work towards that side and give that distance 166 times 3. And as new bodies, because I still want to rotate those two to define our crankshaft. So I will use the transform with the rotate option. Pick that second one and give that a 120 degree. Okay, axis. I'll take this one. Okay. And do that one more time. That part, rotating this 120. And that's it. We got the second section of our crankshaft rotated to the right and the third one to the left. Let's connect those three and call that crankshaft. I'll give some more characteristics to that here at the beginning and end, where those cylindrical faces rest in the engine block. That's called journal. And here at the beginning, so to say, I'll just make a sketch. The circle 122 and extrude that with 22 millimeters, adding to our part. And on this face, I'll make a sketch offsetting that circle to the inside with 6 millimeters, and repeat that one more time with that same value. And then extruding that inner circle with 66, and that outer circle with 22. Okay. We can add some fillets here, and that's it for our first part, the crankshaft. Let's continue with the rod, which connects the crankshaft to our piston head. I will start with a sketch plane creation, 12 millimeters from this face, and then our sketch here. And to make things easier, I'll just go into section view mode with that plane. So first of all, I will project that circle here in our sketch. So I'll draw one circle here with a 96, and a construction line from that circle upwards with a 222. Then take that slot tool here with that line. I can accept that for now, but I will erase that dimension here and apply a tangent constraint here between those two circles. I'll make that circle construction geometry, take X to extend this line over here, and do that one more time. Oops. With that line here. All right, that's defined. And draw one circle up here with 28 millimeters. And now hide that plane, go into the extrude of that face and that one. Make that a symmetric extrusion with 24 millimeters. And this is a new body. All right. I'll stay in that section view mode for now. I'll apply a fillet to that edge and that one. And now I'll quit the section view mode for a moment. I'll rename that part rod, and give that some distinctive color, some dark blue. And to add a little detail, I'll apply a chamfer to that line and that one, 4 millimeters. All right. And now we're ready to sketch our third and last part, the piston head. For this, I will start a plane sketch on that plane we just created, and again I might just go back to section view mode and project that circle here, then take one rectangle, place that here, width is 66 and height is 122. Make that coincident here, and vertical distance of 28 millimeters, and one small rectangle here. I press Alt to make that a square and give that 6 millimeters. And between those endpoints again, 6 millimeters. Okay, now I'll go into the revolve command, take those 3 faces around that axis. I'll make a new body. Onshape indicates me that there is a collision between those 2 parts. I don't worry about that for now. A new part. I'll call that piston and apply orange or yellow appearance, and then I'll continue with the shell of 8 millimeters, removing that bottom face and that collision color disappears. I will go into the extrusion of this face, these 2 faces, merging with that piston head, and go to up to next for first distance, and with the second end position again up to next. Okay, let's have a look at our piston head for now. There it is. And this pin, I didn't want to complicate things too much, so I just included that in the piston head. But I will add it, no, not the whole piston, just that face, add appearance to face. I'll give it some dark grayish color. And now I want to cut into the piston head those notches for the O-rings. So I take that region and go to remove. There it is. And next is a linear pattern of features. Direction is a cylindrical body. Make that 3 times, and with a distance of 16. And that's it. So there we modeled the crankshaft, the rod, and the piston head. And that's it for modeling for this tutorial. I can hide that sketch. And there's another one here. Okay. And next thing, we'll be working in the assembly environment. So we need 6 more instances of the piston and rod. So let's make a sub-assembly of those 2. So from the Part Studio, I enter the piston and the rod. both of those are floating. And I don't need to fix them really. I just want to apply one mate, and that is the revolute mate between this mate connector and this one here in the middle. And whenever you have a difficulty picking the one in the center, you just press Shift on your keyboard and take that. Okay, so just to see the action of this, I'll fix the rod for an instant, and there our piston head rotates nicely around it. I will unfix it and maybe rename our assembly here sub-assembly. Okay, I'll go down here and create our assembly for all parts. And before I start inserting parts here, I will just define two mates, and that is the first one where I want the z-axis in the direction of the y-axis. So I rotate around the x-axis with a 90 degrees here, like this. So this is where I want to position our crankshaft. All right, and I will define one more with that origin, but this time I want the z-axis rotated around the y-axis with 90 degrees, and this will help me to position the pistons. Okay, I'll rename that origin mate with 90 degrees. All right, and now I will insert that crankshaft at first. So this will be a revolute mate with this mate connector and that one. Turn that around, okay. So I can keep that type of perspective of my assembly. And let's just make a test. Okay, and that is how this rotates. That's fine, and I'll just rename that one, because I always want to go back to that one to check my animation. Animate me, I'll call it like that. And now I will insert from the assembly tab here, that's subassembly. And the first one, I will connect with a revolute mate to that position. Okay. And I will define one explicit mate connector here. And this will help me in several ways. One is I'll just measure the distance to the origin like that. And this will help me for my slider mate. Okay, so I'll measure from here to here. That is 122. Great. And now the slider mate between that origin mate here and that one, offset in the y-axis is 122, but negative value. And I accept that. Okay, this is supposed to be the other way around, so I'll just go to mate connector, flip that axis, and yeah, let's check on the action. Great, this works. And to make things easier, we will use one nice command, which is replicate. So I take those two instances, and Onshape suggests that I take that mate, the revolute mate from the subassembly along, and just copy to these faces. All right, so we get these instances, but they still need to be aligned with the slider mates. So I will just again define this mate connector, measure again here. The distance is 288 here, okay? So I go into the slider. Onshape took that mate connector, and I'll take again that one. The origin 90, and that offset was in the y-axis 288. No, it wasn't the y, it was okay, here, the x. So that is 0, and that is 288, but minus. Okay, we get that one defined. Let's do that one more time. Pick that outer edge. Go to measure. Take that 454 value Go to slider, take that one, offset, 4, 5, form. But again, minus. Let's just see how that looks so far. And this is looking good. Now let's continue with the left side. Those three last instances. So I'll go to Insert, Assemblies, Subassembly, place that here. Go to Rotate, take that edge, take that one, flip. There it is. And define that mate connector here. No. Flip that. Measure the distance. It's 146. Let's apply that slider mate between that mate connector and that one. Then with an offset of those 146 and a rotation of 60. Yeah. And okay, let's have a look. The animation. Yeah, that was the intention. And let's repeat that process again of replicating this one here, replicate those two instances and find match with that face here and that one. All right. And then again, apply that explicit mate connector to the, well, first that measurement makes it easier. I mean, you could calculate that, okay, but 312. Slider mate, offset 312, angle 60, accept that, and one last time, mate connector, edge, measure 478. No. Slider mate, that one, offset 478, rotating 60, accept that, press K on the keyboard to hide all mates, go to that animate me, make that loop, and maybe you want to speed things up a little, make that 44 times, and there is our engine rotating the way we wanted it. I hope you liked this tutorial, and I see you in the next one.